everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over translating equations, and we're not translating them from a foreign language. We are taking a mathematical sentence and putting it into an equation. So we're going to give you a sentence of words, and we're going to have to put it into an equation and solve for the variable. So it's important to know our key vocab words that we have seen in the past, but let's just brush up on them to make sure we're all on the same page. So we have the word sum. Sum means addition. Then we have product, which means multiplication. And then we have quotient, which means division. So we've seen the quotient rule this year. Obviously, we've seen addition and multiplication as well, but we've seen specifically that word quotient when we worked with division of exponents. So our division rule of quotient rule of exponents, that's when we specifically saw this year. So that will hopefully give you a little bit of a refresher of what we're talking about. So a point that some of my students made is, wait, on this slide, we don't talk about subtraction. Well, subtraction is sometimes a little bit more complex than our regular addition, multiplication, and division. It sometimes confuses us, so I wanted to expand on it and talk about it a little bit more to make sure we're all on the same page. So subtraction can be seen as less than or subtracted from, which makes sense. If we're saying there's less than or subtracted from, we're taking away. However, it would be seen as 20 less than 30. And some of us might think, oh, we do 20 minus 30. However, we have to think logically. 20 less than 30. That means we're taking 20 away from 30. We're subtracting it away. So that's going to be 30 minus 20, which is 10. If we did it the opposite way, we would get a negative 10, which clearly they're not the same answer. So it's very important that when we have less than, I like to say it's almost like we're reading backwards. We're not doing left to right anymore. Once I see the word less than, I'm going to say, oh, I'm doing 30 minus 20, which is what I have. Or another way to think about it is when you see less than, take that number, put it behind, and subtract it. So there's many ways of thinking about this, but we have to be very careful that when we see less than, we're not just taking the first number minus the second number. We have to remember we're taking that first number and subtracting it from the beginning number or the variable, whatever we are given. Another example would be subtracted from. We are taking 14 away from 19. So we're doing 19 minus 14. We break that down and we get 5. So I always say break it down, break it up. Make sure we're logically thinking what we have to do here. And a lot of translating equations is breaking it up, figuring out what we're working with. So now another word that's very important is the word is. We have another key word is. Anytime you see the word is, put an equal sign. I automatically put the word, if I see the word is, I put the symbol equals above it. So I know I'm putting equal sign at that point in my mathematical sentence, equation, whatever I'm working with there. So automatically put an equal sign when you see the word is. And the last portion is anytime we see the word number, I'm saying a number is, I'm going to put my variable, whatever I'm working with. So I'm going to define it by saying my number is x. This becomes very important when we're working with word problems because word problems we're working with two people or we're working with two things and you want to define what you're working with or we have no clue what you're doing here. So you could be talking about this one when you're supposed to be talking about the other one. So it's important to get used to defining what your variables are so you're able to solve appropriately. Now, I am going to show you some more intense of our translating equations because if you're able to do these, you're able to do more of the straightforward ones. It applies everything that you would see. And so if you're able to do these, you'll be good for any assessment you're given on this topic. So it says twice the sum of a number and 3 is 20. Like I always say, break it up, break it down. Underline what you know and continue from there. So I like to say the sum of a number and 3. We know a number is going to be x is our number. So the sum means addition of a number and 3. So that means we are going to be adding the number and 3 together. So we have a number and 3. The word is, like I said before, you automatically put that equal sign, 20. But now you're like, wait, you forgot about the twice. I did. So twice means we're multiplying the sum twice. This is not saying that we're multiplying our x variable twice. It doesn't say 2 times the number, it's saying 2 times the sum. So we have to multiply the sum by 2 to be able to continue. So it's so very important that if we're saying 2 times the sum or twice the sum. We're multiplying the sum by 2, not just the variable. And now we would solve this like a normal equation. So I would distribute. I get 2x plus 6 equals 20. Subtract 6, I get 2x equals 14. Divide by 2, I get x equals 7. So as you can see, it's so important that we know our solving equation skills. We're doing well with this because if we're not able to solve this equation, then we're stuck at this point. The most important part as well is being able to translate this. So if we can't even translate this, we can't solve the equation. So all these are key points to be able to determine what our final answer is. Let's take a look at another one that includes some of our other vocab words. We have 10 less than a number is 3 more than 6 times the number. So once again, let's break it up. Let's start with the first portion. 10 less than a number. X is our number. So 10 less than a number. I told you, anytime you see the word less than, we're going to read from this way over. So we're going to say x minus 10. X minus 10. We're taking the 10 away from the number. So if you think of it as we have a number, we take the 10, subtract it from there. So 10 less than a number. The word is means equals. 3 more than. So we're adding 3 to 6 times the number. The number once again is x. So we're adding 3 to 6 times the number. We're taking the number and multiplying it by 6. Now we can solve this equation like we normally would. So I'm going to subtract x from both sides. And I get negative 10 equals 3 plus 5x. Subtract 3. I get negative 13 equals 5x. Divide by that 5, I get negative 13. Divided by 5 equals x. So not only do you have to be able to translate it into a mathematical equation, you have to be able to solve that equation. So there's 2 components here, 2 skills that you're very much working on. So key point is remembering that less than means that you're subtracting it from, you're putting the minus behind. A lot of people will mess that up. Let's try one more problem where now we're going to use the quotient rule and see how to apply it. It might be a little bit more challenging than we're used to seeing, but a challenge is always good, right? So now we have the quotient of the sum of a number and 8 is 24. Quotient means division. Sum means addition. Number equals x. 2 is 2. Equals means x. So I'm going to break it up. The quotient of the sum of a number and 8. I'm going to break that down. So the sum of a number and 8 means we're adding the number and 8 together. But we can't forget about the quotient of it. So we're dividing the sum of the number 8 with 2. So divided by 2 is 24. Now we're able to solve this. We did so well on our solving equations chapter. So we're going to multiply by 2 to cancel out the denominator. And I get x plus 8 equals 48. Subtract 8, I get x equals 40. So I can't say this enough. Breaking up the problem is so important. Understanding what these words mean is equally important. So I like to tell my students to break up what you can do. Start with what you can do and add on to it until you get the correct answer. So I'm glad that we were able to see quotient, product, addition, subtraction, all the different types. So we're able to see how to complete these proper equations. So I hope this was helpful to be able to translate equations.